Uh, Students, we are still on projectile motion, and now we are going on the second parameter, that is initial velocity. Initial velocity. But we all know what is the meaning of initial. If we say initial, what comes in our mind? Initial, it is something you start with. Something you start with. So if we add something, if we add another term, velocity, velocity. So we shall define this one is the velocity, the projectile is the velocity the projectile starts with. So now it starts with t is equal to 0 seconds, and it is denoted as v naught or u. So that is what we call the initial velocity. But NB, initial velocity is having two components. It has the vertical component and the horizontal component. Initial velocity is having two components, i.e. horizontal initial velocity, and then vertical initial velocity. So horizontal, it is denoted by Vx, and then the vertical by Vy. How can we derive their formulas? Now look, if we need to see the formula of horizontal and then the vertical component of initial velocity, then we shall sketch this diagram. All of us, we know that this particle, which is our projectile, is moving with the initial velocity, which is v naught. But this v naught is divided in two components. We have horizontal, that is the velocity is using on horizontal plane, and then the vertical, which is Vy, which is the velocity used on the vertical plane. For example, if we need the horizontal or the initial, number one, initial horizontal velocity, which is our Vx. If we need it, then it means that we need now to get Vx, which is on horizontal, with relation with this hypotenuse, which is a v naught. But we know that if we need this adjacent, always we use cos, because we know that cos theta of any angle, maybe theta, is equal to adjacent over hypotenuse. For this case, cos theta is the same as adjacent is our Vx, and then hypotenuse is a v naught. Then if you cross multiply, you realize this is over 1. Cross multiply, this goes with that, we get v naught cos theta is equal to 1 times Vx, we get Vx. Therefore, we shall conclude and we say horizontal initial velocity, which is our Vx, is equal to v naught cos theta. Initial component of the velocity on horizontal is that. 2. if we need the vertical initial vertical component of velocity will be what? Which is our Vy. Now we shall look on the vertical, which is this, because now this is a vertical, then it means that also here we have our Vy. Then now we shall now need to resolve vertically. And if we need now a vertical and with relation with that angle, we know that angle is opposite to Vy. Something opposite, then we can use sine. We know sine of any angle, maybe theta, is opposite over hypotenuse. Then our sine theta will be equated to opposite is our Vy over hypotenuse, which is a V0. This is over 1, cross multiply. You obtain your Vy is equal to V0 sine theta. So that is the expression of the initial vertical component of velocity. And this is the expression for initial horizontal component of velocity. This is for a vertical. Thank you for attending.